the final day of the symposium on multi-stakeholders engagement in forest protected area governance for conservation and livelihoods. We are now in the final session and we're going to talk about REDD+, which is an acronym for Reducing Emissions from Deforestation and Forest Degradation. Well, ladies and gentlemen, you may be aware that in order to conserve natural forests from degradation and deforestation, and also to improve livelihoods of forest-dependent communities in developing countries, the United Nations has been implementing REDD+ projects. There are many successful examples of REDD+ projects in Global South. So in this session, we're going to have experts share their studies on REDD+. And ladies and gentlemen, please take note, as per usual, we're going to have a live Q&A segment after all the speakers have presented. So kindly pose your questions on the platform and they will answer all of them if time permits. You should be able to see a question box on your platform. If you don't see it, don't worry. Please just refresh the page and the box should pop out, okay? Now let's get started. Moderating this session will be our chairperson, Dr. Tapan Kumar North. He is, Dr. Tapan, thank you. It's good to see you again after the workshop this morning. Thank you so much for chairing this session as well. So ladies and gentlemen, Dr. Tapan is an associate professor of the School of Environmental and Geographical Sciences at the University of Nottingham, Malaysia. He is a social scientist with experience in applying socio-ecological and sustainable livelihood frameworks for collaborative natural resources management and livelihood analysis of forest-dependent communities. Prior to his role in UNM, he worked at University of Chittagong, the University of Tokyo, and Asian Institute of Technology at various levels. His current research focuses on interaction between nature and society, particularly the forest-dependent communities. His research interests include stakeholders' participation in forest management, livelihood analysis, sustainable intensification of agroecological practices, and urban green spaces and human well-being. So here we go. Please give a warm welcome to Dr. Tapan. Please take it away.
Hi, Vanessa. Thank you so much for this lovely introduction of this session, as well as introduce myself. So ladies and gentlemen, this is our last session in this 5-day-long symposium. And the theme of this session is very important. As we know, REDD+ is a mechanism that provides some incentives to the local communities as well as the other stakeholders to conserve the primarily the natural forest from further deforestation and degradation. And as you know, we have many successful stories of REDD+ in many developing countries. So today we have 3 speakers, in fact 4 speakers, who will share their experience working with REDD+ in Nepal, in Tunisia, as well as in Malaysia. So we have 4 speakers. So first speaker is Vijay Thakur. He is attached with the Faculty of Forestry, Agriculture and Forestry, University, Nepal. And since 2013, he has been teaching different forestry subjects, including wood anatomy, forest mensuration and biometrics, harvesting and logging, and wood products utilization. His research has included the topics of forest carbon sequestration, a case study from Suri landscape of Bara district, Nepal, and status of dead woods and their contribution to carbon sequestration, a comparative study in community forest and protected forest types of Nepal. So it will not be possible for him to present live. So he shared his recorded presentation with us. So I have shared the link in chat box. Please open the link and try to listen to his speech.
It's me, Vijay Thakur, instructor. I am working as an instructor at Faculty of Forestry, Agriculture and Forestry, University, Nepal. Topic of Our research work is a study of forest carbon sequestration, a case study of Chudel landscape of Barat district, Nepal. We were 4 persons in the team: Vishnu Hari Wagle, Deepa Paudel, myself, Vijay Thakur, and Bimal Kumar Acharya. Introduction background: about 43 to 50% of the dry biomass of tree is carbon. Carbon fixed within plant biomass ultimately enters the soil, where it may residue for hundreds of years. Trees both in above and below ground biomass continue to accumulate carbon until they reach maturity. At that point, about half of the average tree's dry weight will be carbon. Atmospheric carbon, which is widely recognized as a key contributor to global warming, is mainly stored in the biomass as well as in soil, which reduces the concentration of greenhouse gases, especially carbon dioxide, in the atmosphere. Removal of carbon from the atmosphere by storing it in the biosphere is called carbon sequestration, which is one of the important environmental services provided by forest ecosystem. Land use change, especially the conservation of forest to agriculture land, results in removal of trees, which displaces a large amount of sequestrated carbon and consequently reduces that held in the terrestrial biomass. The payment was made on the basis of scientifically measured performance in carbon sequestration. Problem analysis: the Tarai forests are mostly confined to the environmentally sensitive Churia Hills or Shivaliks in many districts, and in some, the Bhavar zone immediately to the south of these hills. The Tarai plains themselves are largely devoid of large forest, with the exception of some districts, mainly in the far west. The Churia Hills of its region are not only structurally weak, but also they lie in a high volume precipitation zone. Secondly, the Chure forests constitute Nepal's only continuous east-west corridor for linking similar areas of vegetations across the country, and thus preserving biodiversity by ensuring variable habitats for a wide variety of megafauna. As it provides various environmental services to other regions of the Churia area, Bhavar, Dun, and Tarai, it should be treated differently and with priority. In order to assess the impact of deforestation and regrowth rates on the global carbon cycle, it is necessary to know the stock of carbon as biomass per unit area for different forest types and conditions. The above ground biomass and below ground root biomass both need to be measured to enable better calculations of total forest carbon. Reducing emissions from deforestation and forest degradation has emerged as an incentive mechanism for developing countries. However, updated national forest inventory data and technical capacity is poor, and accounting of change in forest cover biomass stock, carbon emission, and carbon removal are limited in developing countries like Nepal. Therefore, this study has endeavored to assess the carbon stock in the forest of Churia range. Objectives: to estimate per unit area above ground, below ground, and soil organic carbon stock in the forest of Churia range of Barat district. To evaluate the effect of aspect in carbon sequestration. Literature review. These are the literature reviews. Methods of biomass estimation. Worldwide, numerous ecological studies have been conducted to assess carbon stocks based on carbon density of vegetation and soils. The results of these studies are not uniform and have wide variations and uncertainties, probably due to aggregation of spatial and temporal heterogeneity and adaptation of different methodologies. The methods adopted for estimating carbon stock in forest areas vary with respect to geography, objective of the study, available expertise, data, and scientific excellence adopted. Adoption of carbon inventory methods and guidelines should lead to accurate, reliable, and cost-effective estimates of carbon stocks and change for a given land use system and period. Chave Chave et al. Have compared a number of statistical models commonly used to estimate above ground biomass in forestry literature and found that if diameter, height, and wood specific gravity of a tree are available, its AGB is easily estimated irrespective of tree species and stand location. It has traditionally been assumed that the carbon content of dry biomass of the tree was 50%. However, it should be emphasized that wood carbon fraction may exhibit some small across species variation. Methodology, study area. Two community forests, namely Bandevi and Mahila Milan, were selected purposefully after the consultation with the DFO BARA officials and respective CFUG members, considering that the selected community forest would represent most of the heterogeneity in terms of slope, aspect, forest types, and so on of the Chure forest. Both Bandevi and Mahila Milan community forest lie in the Amleganj BDC, ward number 8 of the Bara district. Most of the area faces towards northern aspect in Bandevi community forest, whereas the towards southern aspect in the Mahila Milan community forest. The Chure region is the most fragile among the geographical regions of Nepal. The Bandevi and the Mahila Milan community forest were handed over as community forest on 2065 and 2066 Bikram Samvat respectively. Total area of the Bandevi community forest is 133.56 hectare, whereas it is 199 hectare in Mahila Milan community forest. The Sodia robusta, terminalia elata, Syzygium cumini, Legadostromia parviflora, etc. are the major tree species found in this forest. Data collection, size and shape of the sample plot. Nested circular plots with horizontal diameters ranging from 0.56 to 8.92 meter were laid out for quantifying different carbon pools. Circular plot of 8.92 meter radius was established for the measurement of tree, and inside of the 8.92 meter radius plot, a subplot with a 5.6 meter radius was established for saplings. A subplot with a 1 meter radius was established for counting regeneration, and a subplot with a 0.56 meter radius was established for sampling leaf litter, herbs, grass, and soil. Forest carbon pools. Description of different carbon pools considered under this study are provided in this section. Sample plot measurement. Above ground tree biomass. The DBH and height of individual trees greater than or equal to 5 centimeter DBH were measured in each permanent circular 2005 meter square plot, that is 8.92 meter in radius, using diameter tape, Ebony's level, and linear tape. Each tree was recorded individually together with its species name. Above ground sapling biomass. Nested subplots having a 5.64 meter radius inside larger plots were established for sapling measurement. Saplings with diameters of greater than 1 centimeter to less than 5 centimeter were measured at 1.53 meter above ground level and recorded with its species name. Regeneration count. The goal of quantifying regeneration data is to analyze the regeneration status of the project area. This helps to plan processes for further forest enhancement and sustainable management practices. One circular subplot of 1 square meter, that is 0.56 meter radius in size, was established at the center of each nested plot, and destructive sampling was applied to measure the leaf litter, herbs, and grass biomass. All the litter within the 1 meter square subplots were collected and weighed. Approximately 100 grams of evenly mixed subsamples were brought to the laboratory to determine moisture content, from which total dry mass was calculated. Soil sampling. Soil organic carbon was determined through samples collected from the default depth prescribed by the IPCC near the center of all plots and or subplots. A single pit of up to 30 centimeter in depth was dug and 3 individual soil samples, one each from 3 depths 0 to 10 centimeter, 10 to 20 centimeter, and 20 to 30 centimeter were collected with the help of a standardized metal soil sampling core of 100 centimeter cube size. Laboratory work. The samples of leaf litter, herbs, and grass were dried inside oven in a lab of Institute of Forestry, Hetera, until their weight becomes constant and oven dry weight of the sample was recorded. Similarly, soil samples were taken to a lab at Regional Lab, Hetera, where it was dried in oven for moisture correction. The dried soil was then passed through a sieve of 2 mm to determine volume of stones required to determine the bulk density. Soil organic carbon percentage were measured using Walke-Black method. On the other hand, the Chave group considers wood specific gravity of each plant species one of the important variables in the biomass function. This model was also tested with 5 other models in Uttar Pradesh, in India, similar climatic conditions and vegetation types with Nepal. They found more accurate results from this model than others, so the Chave ETL regeneration model was used for this study. AGTB is equal to 0.509 into rho d square h. This value was then multiplied by 10 to get the biomass stock in ton per hectare. Since the study area is a part of the tropical and subtropical region, the biomass stock was converted into carbon stock after multiplication with the IPCC default carbon fraction of 0.47. Above ground sapling biomass. National allometric biomass equations were used to determine the above ground sapling biomass. These tables are developed by the Department of Forest Research and Survey and the Department of Forest, Tree Improvement and Silviculture Component, Nepal. In case of tree species other than given equations in the biomass table, equations were applied according to the given association of species. Thus, the following equation was used to calculate the above ground sampling biomass. Log AGSB is equal to A plus B log D. Leaf litter, grass, and herbs biomass. The samples of leaf litter, grass, and herbs were used to extrapolate leaf litter, grass, and herb biomass per hectare by using the following formula, and carbon content was determined by multiplying with IPCC default carbon fraction of 0.47. LGH is equal to W filled by capital A into W subsample dry by W subsample weight into 10. Below ground tree biomass. Methods for estimating below ground biomass for different land use systems are still not standardized. The soil organic carbon. The carbon stock of soil organic carbon was calculated by using following formula. SOC is equal to rho into D into percentage carbon. Results. The average DBH were only 13.5 centimeter and 15.8 centimeter, and the average height were 8.3 meter and 9.8 meter in northern and southern aspects respectively. Similarly, based on the combined data of both aspects, the average DBH and height were found to be 14.8 centimeter and 9.1 meter respectively. Nearly 90% trees were below 30 centimeter DBS. Thus, the data shows that both the strata northern and southern aspects are relatively young, indicating most of the trees are younger, and there is a potential to enhance forest carbon stock by encouraging tree growth. This is table 1. Above ground tree biomass. Based on pre-analysis plots and with extreme biomass values were identified within these plots with extreme biomass values, individual tree with potential outlier variable values, that is DBH and height, were identified. Figure 3 illustrates the status of forest based on 3 observable variables, that is biomass, tree density, and basal area in southern and northern strata. This is figure 2. This is table 2. Above ground sapling biomass. Table 3 reveals that all overall per hectare values of all AGSP variables, that is biomass, tree density, and basal area, are higher in northern aspect. Minimum values column suggests both the strata have at least one plot without any sapling. Similarly, figure 4 illustrates that the northern aspects has higher spreading of the AGSP than in southern aspect. Though the mean value of AGSB in northern aspects seem to be greater, independent samples t-test revealed that there is no significant difference in the mean value of AGSB of northern and southern aspects. This is table 3. This is figure 4. Herb and grass biomass. The summary of statistics of herb and grass biomass has been presented in table 4. The southern aspect has the higher SGB than the northern aspects, and the northern aspects has the higher spread of the SGB value as illustrated in figure 5. While comparing the mean value of SGB biomass by using independent samples t-test, it was revealed that the southern and northern aspects did not differ significantly with respect to the SGB they had. This is table 4. This is figure 5. Leaf litter biomass. Northern aspects has the higher spread of leaf litter biomass value as illustrated by the figure. Similarly, figure 6. Similarly, some summary statistics of the LLB in 2 different aspects are shown in table 5, which reveals that the LLB per hectare is higher in northern aspects. However, the independent sample t-test showed that there is no significant difference in the LLB of northern and southern aspects. This is table 5. This is figure 6. Below ground biomass. The summary of mean below ground biomass has been presented in table 6. This is table 6. Above ground biomass. The above ground carbon stock in different carbon pools are presented in table 7. This is table 7. Below ground biomass carbon. The per hectare below ground biomass carbon of both northern and southern aspects are presented in table 8. This is table 8. Soil carbon sequestration bulk density. There is a gradual increase in soil bulk density with the increase in soil depth as shown in table 9. This is table 9. Soil organic carbon. The soil organic carbon was higher in upper layer and gradually decreased with soil depth. The maximum soil organic carbon was found in topsoil 0 to 10 centimeter and minimum soil organic carbon at 20 to 30 centimeter depth in both southern and northern aspects, which is shown in table 10. This is table 10. The figure 7. Total forest carbon stock. Total forest carbon stock is the sum of above ground carbon, below ground carbon, and soil organic carbon. The total carbon sequestration in the northern and southern aspects were 130.96 and 145.72 ton per hectare respectively. This is table 11. Conclusion. Carbon sequestered in 4 different carbon pools, namely above ground biomass, below ground biomass, litter, and soil carbon has been quantified for the community managed forest in Chude area of Bara district, Nepal. Dead wood carbon has not been estimated as it is frequently removed by the local communities for fuel wood purposes. The study has revealed that forest area in the southern and northern aspects of Churia Hill are the homogeneous with respect to the carbon sequestrated on them. These are the references. Thank you.
That's a good presentation from Vijay from Nepal. So this community forest, so we can understand it has huge significance in terms of a biodiversity hotspots, and they also did a comprehensive study to measure the carbon sequestration potential that can be used for REDD+ mechanism. And we believe this kind of study is very important because we need to understand the potential of carbon mitigation that community forest can have. But unfortunately, we don't have a scope to interact with Vijay because he could not join with us in the Q&A session. So we should thank him for this very comprehensive study. Ladies and gentlemen, we can move to our second talk on institutional pluralistic governance, the case of a research action in the context of the REDD+. So we have Dr. Reem and Associate Professor Jora here with this presentation. Reem, she has a PhD in management theories of organizations from the University of Manova, Tunisia, and has consulted on projects with several international organizations. Her research focuses on NGO management, development, institutional arrangement, social innovation, and multi-stakeholders engagement. And Professor Jora has a PhD in management, more specifically public management, from the University of Paris, Panthéon, Sorbonne. And she's an associate professor at the Higher Institute of Management of Tunis. She teaches human resources, corporate restructuring, and industrial relations. She has coordinated several cooperation projects on social inclusion and social dialogue, and her research focuses on action learning and social innovations. And ladies and gentlemen, for your information, a revised version of this paper already published in Journal of Sustainable Forestry. So congratulations both Reem and Jora for this contribution. So both of them will present not in live, but we can watch the recorded video. And then both of them will join with us in the Q&A session. So ladies and gentlemen, let's watch their recorded videos.
Good afternoon. First of all, I would like to thank the organizers of the symposium for this opportunity to share with you the Tunisian experience and to know more about practices and lessons from different experiences in the South. Rimbo Hafa and my colleague Zahra Busnina will discuss the institutional pluralistic governance, a case study of a research action in the context of the REDD+. Before starting, I would like to take a moment to briefly point out that when we were approached to implement this mechanism, we had just completed the research work on women's collecting clams, as well as on the management of the oasis in the south of Tunisia. The studies aimed at the empowerment of local population, livelihood, resilience, and sustainable natural resources management. The sum conclusion of this work underlined the complexity, the large number of actors intervening in the field, the significance of local culture and community leaders, and the limits of the tools of international organization. This work showed also the significance of the socio-cultural factors. We were very inspired by this observation, and we proposed to experiment a new perspective on REDD+. The time allocated does not allow us to present in detail the process, and the results we come to in our study, but we shall first introduce REDD+ pluralistic governance, then we will move into the rethinking of this mechanism implementation in the Tunisian context. Thirdly, we will discuss the process of the research action, and finally, we will conclude with highlighting the main findings. As you know, the REDD+ as a mitigation mechanism offers a significant potential for reducing emission from deforestation, degradation, and help conserve existing forest carbon stock. Therefore, since 2008, the scientific community, international organizations have been attempting to define the main issues of REDD+ governance, but without finding defined policies to be adopted, given the multiplicity of national contexts and the complexity of the mechanism. Thus, our research focuses on the interest of the research action to adopt and adapt REDD+. Usually, the implementation of REDD+ requires taking into account actors' expectations, interests, existing policies governing forests at the national and local levels, and also transformation of regulatory and governance frameworks according to the requirement, risks, and safeguards of this mechanism. Therefore, the main challenge remains in how to reconcile social, economic, and natural levels and transform the institutional governance by including social justice. As argued by many scholars, a participatory approach is needed to overcome these challenges. A part of the noted challenges, the specificity of each context requires a particular attention. Indeed, the Tunisian forest ecosystem supports 10% of the Tunisian population. From a climatic point of view, Tunisia is one of the vulnerable countries due to the limited natural resources and the arid climate, where the growth rate can reach plus 2.7 degrees Celsius, according to the World Bank. From a governance management point of view, there is a large number of structures and committees involved in the climate change governance, and there is a lack of autonomy of local actors. So coordination and communication issues are among the main problems. The key issue in the various actor governance is to ensure a coherent implementation of the REDD+. So the permanent arrangement must be at the center of the pluralistic governance. We have thus deemed that the use of the economy of work in the actor network theory allows us to provide an analysis framework to this research action. The economy of work helps to explain the future anticipation of conversion and facilitate the discourse, interests, and justification analysis. The actor network theory helps to identify the paradoxes and to analyze the process of appropriation, transformation, and adaptation of the actors' interests. Regarding to the handled problems at various levels, such as land use, information system, regulatory framework, this approach allows rethinking the paradoxes and issues by taking into account the capacity to deal with this complexity. Thank you for your attention, and now I give the floor to my colleague to present the research action process.
This action research took place between 2015 and 2016. The process of data collection and analysis had 3 steps. The first step focused on the observation of the actors' interactions and negotiation with key actors. This step allowed us to target the problem and identify the paradoxes, conflicts, capacities, limits of each actor and daily practices. The second step focused on the main problem and the possibility of agreement between a lot of various actors such as local population, NGOs, agriculture ministry, informal actors, and so on. Finally, the third step aimed at the appropriation and the adaptation of change. The focus was on the involvement of actors and the identification of coordination and communication mechanisms. Based on translation and negotiation, the action research is called as a sense-making process. All this process led us to highlight practices that co-create social value. So we successfully translate the actors' understanding based on the facts, their stories, and their interests to ensure the appropriation and the active commitment of non-state actors. We mobilized and moved the objectives of each actor towards more or less acceptable objectives. We discussed paradoxes and actors' conflicts according to their motivation, expectation, and needs. The main results of this action research showed us how negotiation is a key concept in the pluralistic governance of a national REDD+ program. The action research process remains a way to integrate the actors according to a translation and a sense-making approach. For the Tunisian specificity, forest community leaders are also to be represented in the decision-making structure at the national level. In order to participate in the development of REDD+, project ideas need to be convenient to the community leaders and in line with the local culture. To conclude, we would like to emphasize that both translation and negotiation generate a more specific meaning to the practices that are inherent to the reality of the context. Proximity of forest community, in-depth analysis of populations, and leader awareness are therefore unavoidable. I hope this has been informative and useful for you, and would like to thank you all for your attention.
Thanks, Jim, Rim, and Jora for this excellent work. So forest nowadays is about interaction with many actors. It's not just managed by the forestry department. Many organizations, many individuals, many local groups are involved in the forest management. So whenever we implement any mechanism, if it is REDD+, definitely we should have to consider all these stakeholders. And we need to ensure the good governance practices. And in that sense, this paper is an excellent work that you did. You want to discuss the evidence of pluralistic governance if we want to implement REDD+. Thanks for your nice presentation. Now we have our last presenters, Shiro Shikamasu. He will talk about Malaysian REDD+ and the possible roles of non-state actors. Sean, could you please share his bio? Sean? Sorry, I don't have his biography. Oh, thanks, Sean and Hafiz. Shiro Shikamasu is Director or Principal Consultant at Ecological Economic Solutions SDM Barhat, and co-founder or principal consultant at Nature Inclusive LLC. His specialties are natural resource management, climate change mitigation and adaptation. And over the past 10 years has consulted and advised government agencies, companies, and NGOs on topics such as National Adaptation Plan, responsible sourcing of soft commodities, corporate sustainability management, REDD+, clean development mechanism, carbon offset and carbon accounting, species conservation, forest fire mitigation, ecotourism and sustainable tourism, ecosystem services, and climate change mitigation and adaptation. So now floor is Shiro Shigamasu. So please share your experience with us.
Okay, thank you very much. Can everyone see the slide now?
Yeah, we can.
Okay, that's great. So, well, thank you very much for the opportunity. My name is Shiro Chikamatsu. I'm a consultant working in ecological economic solutions. And today I want to talk about REDD+, but I think REDD+ can get very abstract. So I want to give you some very specific example. And this example actually is not a REDD+ project, but when we look at the example, we can think about the REDD+ project. I think you will understand as I explain along. So I came across, and this project is not Malaysia. This is in Bali, Indonesia. And I came across this mangrove reforestation project when I was involved in a different reforestation project. And the guide or the ecotourist actually recommended me to come and visit this place where the community themselves did the reforestation. And it's not like an internationally or nationally funded large-scale project. It's a very small project. I think it's around 25 hectares of restoration of mangrove forest. And I think what's interesting about this project is the longevity of this project. So if you look at the satellite image in 2003, it's like you can see it's quite degraded. And the reforestation started in 2005. And when I visited, it was around 2013. And when I checked the recent satellite image, in the one I could get was March 2021, you can see that the forest is intact. So they've been maintaining this forest. And some of you may be aware that in December 2004, there was a tsunami. But this photo of July 2003, so it's this photo of the degraded forest is before the tsunami. So, but the reforestation started after the tsunami. I think a lot of mangrove reforestation projects started around that time. So, including this project. The reason is quite interesting. So the reason why the village decided to do the reforestation is if you look at this aerial image, you can see like the squares, and these squares are actually salt ponds. So this is where they produce the salt. So they have a very shallow water and they dry and then they collect the salt. And another thing is this land is right next to the sea. And if you look to the picture on the top right, you can see there's a coastal degradation. So coastal erosion. So it's quite severe, and the villagers were quite concerned about this coastal erosion, and that's one of the main driver for them to do the reforestation. So this is just a simple diagram to illustrate what happened. So there was a salt pond in the village, and there was a lot of coastal erosion. So the villagers decided to do the reforestation. And the location of the village is in the it's called West Bali, so the west side of Bali, near Java. And there was a coincidence where there was another project near the capital Denpasar. This project is called Mangrove Information Center Project, which was Mangrove Information Center Project, which was funded by international agency, in this case, JICA. And what they did was that they restored some of the abandoned shrimp pond into mangrove forest, but also they built a nursery so that all the mangrove seedlings were kept there. So what the villagers did was that they actually purchased the seedling from the Mangrove Information Center, and they got some subsidy from the local government as well to do it. So that's how the project was realized. And on top of that, the village is actually next to a national park, and also there's a famous diving spot nearby. So they wanted to actually also establish an ecotourism, because it's very close proximity to a touristy area. So that was the whole picture of this mangrove reforestation. And I think what we can learn from it is that, first we need infrastructure. So in this case, the villagers needed somewhere to purchase the seedling, and also they could get assistance from how to plant the seedling. So the technical capacity is also important, as well as financing. But I think the most important part in this case is the local needs. So the villagers wanted to prevent the coastal erosion. So there was a very strong local need. So that's why, after more than 10 years, it's still ongoing. The mangrove is still there and still well maintained. And so what I could say is that I think we need both top-down and bottom-up approaches. So that, there was the JICA funded project that enabled the community project. And I think what is important is the coordination of the both top-down and bottom-up approaches. And I think NGO can play a very important role in terms of coordination. And when we think about REDD+, there are some problems, especially when you want to do these kind of small-scale community projects. Because first of all, REDD+ projects are usually very large-scale. And it can be very technical. REDD+ is already an acronym. And it's usually top-down. And because we don't have the high-resolution climate modeling. So this just means that we don't know what's going to happen in the future for that particular area. So for example, the Bali village that we saw, we don't know what kind of sea level rise we will be expecting in like 2030 or 2050 or 2100. 2100. So we lack the high resolution climate modeling in order to do small scale projects. And when we think about REDD+, there's also the topic of carbon market. And there's also a disparity between market demand and local needs. Especially when we think about community forest of this type. Usually the buyers, they want a large scale project with lots of emission reduction and very, very accurate MRV. MRVs means monitoring, reporting, and verification. The project should have minimal risk and no uncertainty. And usually they want to pay after the credit is issued, means that, after the reforestation happened, everything get monitored and the credit get issued and they want to pay for that. On the other hand, if they're from the community side, they want something small scale with simple MRV, and usually the places they want to plant can be like high risk and also uncertain, and also want prepaid option so that, they can cover the upfront cost. So I think there's a kind of disparity when we think about REDD+, trying to implement at a very small community level. I think it works very good, for example, on a large scale from like G2G or from the international agency to like large scale project. But when it becomes investing into smaller projects, I think these are some of the problems that we face. And I just want to go back into Malaysian context. So these are some of the solutions. And in fact, in Malaysia, there is quite a good project. I think it's quite low key, but it's called, I describe it as a National Coastal Reforestation Program. It's happening from 2005. Basically, it's this program is funded by the national government to restore the mangrove in the coastal area. And I think what's good about this program is there is also the participation of the NGOs, including Malaysian Nature Society. But I think what it can be improved is that, I think that this kind of NGOs and also local communities participation can be strengthened in these kind of programs. I think that would be very helpful. And as I mentioned, if the NGOs are involved, they should bridge between REDD+ policy and practice. I think they'll have a key role in this context. And finally, I just want to go briefly. I think there can be idea of a domestic voluntary forest carbon market or other financial mechanism to facilitate transition. This kind of financing mechanism to finance community forestry can be developed. And it's a bit difficult to explain in a few minutes, but basically if, for example, a Malaysian company reduce the emission, maybe from going from a car to a bicycle, there's still amount that GHG emission that they cannot reduce. That part they can offset with a reforestation program. And the reforestation program can also be a transition. So that transition is from a program that has no economical value into a more forestry with an economical value, with like a forest positive economy, something, for example, like ecotourism. So in order to achieve that transition, they need investment. And that investment could come from this kind of carbon offset project. I think that kind of new relation or new thinking into the carbon market would help because in the end, we have to transition into a zero emission economy. So in order to achieve that, we can use the carbon offset as a means to achieve that goal. Okay, so that was very brief. But if you have any question, or if you have any, if you want further information, you can always contact me. Okay, thank you very much.
Thank you very much, Dr. Shiru. It's very informative presentation. And I should say it's very encouraging project for the community people who are managing community forest. And as you said, REDD+ mechanism is a complex mechanism. And for a smaller scale community forest, in most of the cases, it's not feasible because transaction cost is too high in case of REDD+. So in that case, probably we can try to have some alternatives. And that what you have suggested in your presentation. So we have just 6 minutes. Maybe we can take 2 questions. So we have 1 question for speaker 2. How can we build trust between stakeholders to implement this pluralistic governance approach for REDD+ implementation? So if you can briefly address this question, Rim.
Okay. Zora, it's Zora.
Okay, Zora. Yes.
Response. Yes. To answer this question, we can say that we need a constant reflexivity on our practices that lead to empowerment of local population and different actors. This need to build confidence among actors and to be aware on the role of leadership. We must also take time to understand the actors and their culture, to focus on culture, dialogue culture. We have also to go back and forth between pressing social, environmental issues and long-term responses. That's the point, briefly.
Yep. Thank you. Thank you, Jora.
Okay.
Rim, you want to add something?
I have a question for
Nepal
Nepal experience or Malaysian experience.
Yeah, please.
In Africa, currently in Africa, criticism is directed at carbon markets and benefit sharing through REDD+. And many countries are thinking about the possibility of developing a local or regional carbon market. What about Malaysia or Nepal? Yeah.
Shiro?
Are you advanced?
Okay. Maybe I can talk about, I'm not sure about Nepal, but in terms of Malaysia, I think there is within the government consideration of developing such a domestic market in Malaysia. And I think when you look at the world example, there's quite a lot in, like California is a famous one. Also, I think New Zealand, they have their like forest market. And also, I think Japan also have. And other various countries also have this kind of scheme. So I think the advantage of the domestic one is that, you know, when we think about the leakage issue or the, you know, whether the emission reduction contributes to the NDC, the emission reduction commitment of each country, you know, because if you sell it to the other country, then that emission reduction, the country have to achieve in another way. You know, and the forest emission reduction is one of the most cost-effective way to achieve emission reduction. So I think, so that part we is still in the discussion. And I think globally speaking, all these REDD+ players understand this problem, and I think this would be discussed in the next COP meeting. Yeah.
Yep.
Thank you.
And
thank you.
Shiro, just I can take one of your question. What kind of REDD+ policy could support community forestry project?
Okay, so I think the easiest way to start this kind of REDD+ is to try to recognize this kind of small community project and put within the REDD+ database. I think NGOs have a lot of this kind of project, but they don't really understand it as REDD+, you know? They don't think this is a REDD+ project, but it is a REDD+ project because it's about reducing emission reduction, deforestation. It's about reducing deforestation, and it's about restoring the forest. So anything to do with that, it should be included in the, for example, the national database. So I think that's one of the first step to do. And I think the second step, ideally, will be to try to invest for the maybe for the national or the local governments and the international community to invest in a smaller community forestry project as well. So I think that will be the second stage.
Thank you so much. Thanks, Shiro, Rim, Jora, and Vijay for your excellent presentations. It will be useful for Malaysian authorities as well as in other countries, I hope. So we have just more than 1 minute. I should hand over to Vanessa. Hi, Vanessa.
Thank you. Thank you, Dr. Tapan, for doing this again. You've been amazing, chairman and moderator. Also, massive thanks to our speakers and audience for joining in. I'm sorry that we do have quite short time this time around, but we're going to have the closing ceremony. So I really hope everybody do join me. But going on the topic that our speakers spoke to there, I personally hope that we all seriously fight to achieve zero carbon emissions sooner than the targeted 2050. I don't know. I'm just being very hopeful. Fingers crossed. But anyway, this concludes our series of 8 sessions. It has been an amazing and insightful week with incredible speakers. We are going to round up all the key points of discussion at our closing segment at 5 p.m. later. So please do join in the discussion to ensure that the outcome of this week-long symposium is a fruitful one that will spark up positive changes moving forward. So I'm going to see all of you again at 5 p.m. Thank you.
Thank you.